Good afternoon, good evening. So I am Jérôme Dubuc. I will present the expander technology of Amandus Kahl for you. So I work for Amandus Kahl for quite some time, and I am in charge of the Southeast Asia market, especially Indonesia, which I spend a lot of time already. So let me share. Introduction of the Kahl Expander, Kahl feed technology. So here we have the list of contents. I will start by the introduction, then followed by the machine design, the process, the additive, the control, the wear detection, and the data from the market. So the keyword we need to remember for the expander, they are pellet quality, feed conversion rate, capacity, hygiene, monocomponent treatments, animal nutrition, cost saving, user friendly, and full-scale industrial machine. So the expander is made to create success for everybody. When we talk about formulator or nutritionist, we will often mention cost saving or lower cost ingredients, a feed adapt to the animal need. For the feed mill operator, we will get a better pellet quality and higher capacity with the pellet mill and the pelletizing line, a good hygiene, and higher plant efficiency, easy to operate and easy to maintain. In the marketing and the sales side, we will have feed, which is easy to reproduce with high quality, high hygiene, and high nutrition features and improved digestibility. For the farmers, we will always see a better feed conversion, a lower mortality, and less dust due to the better PDI of the pellet and the crumble. The machine design. So we can see here our latest model for the expander, where we have the inlet. The feed will come to the machine through this side, go through the barrel with the shaft and tools, then end up to the movable cone. Once the product is released from the cone, it will go to the structurizer to make a finer structure to be able to pelletize it. We have a direct steam injection used generally for monocomponent treatment and also for some high intensity or high temperature need in the barrel. Then we have the hydraulic units to activate the movable cone. Here we have a single hydraulic cylinder, which is operated by the hydraulic system with a quick acting in case of jam or overload in the machine. It's important to know that at the end of the batch, the cone will be fully open to allow the machine to be fully emptied. Underneath the structurizer, it's a double shaft with knife, and the screen can be changed and adapt with the different size of hole, depending on what structure you want and what size of pellet you want to pelletize. Here we have the view of the inside the machine. So the inlet thread have a progressive pitch, which will go to the stop bolt, where the stop bolt will have a kneading action through the barrel. We have the steam nozzle to inject the steam. And further down, we have very low pitch paddle. We have the lining and the outlet cone with the movable cone. Those parts are made to be changeable easily by the maintenance team or the operator in the plant. In the process, so the expander provides for HTST, so high temperature, short time process, and HPST, high pressure, short time process. Inside the expander, we have a mixing, kneading, homogenization, and agglomeration of the product. The process of the machine will make decomposition of plant cells and microorganisms by means of expansion. So it means that when the product is compressed and expand, all the microorganisms will be break open. The temperature increase in the expander is at the outlet. Generally, depending on the feed we treat, we will go from starting at 75 degrees and end up at 120, sometimes 130 or 140 for monocomponents. The high temperature will last only half second or 1 second. So here you can see the infrared image of the temperature. And we can notice that the high temperature is only at the cone area for a very short time. So expander temperature and pressure increase. So here, when the products enter in the machine, it will go into pressure to the cone. So the pressure will create an increase of temperature due to the friction, what we call the mechanical energy or the kilowatt hour per ton. So here, at the last part of the expander, we will see the rise of temperature with the pressure. Here we can see the treatment effect on the wheat kernel. So we can see the kernel untreated. So we don't have any starch modification here. And all the cellule and the wall are intact. In the second picture, we will see with an expansion at 100 degrees that the starch is already modified, and the modification is around 30 to 40%. In the third picture, we have a treatment at 120 degrees, where the starch will be modified at approximately 60 to 70%. And in the last picture, this is very high modified starch at 90% or above. So we can see that all the protein is open for better digestibility. We generally use those high treatment for monocomponent only when we want to treat single kernel or a single product like soybean meal, rapeseed, corn, or wheat, copra as well. And now we go a lot with the palm kernel meal. And picture 1 and picture 2 is more for the mixed feed as chicken feed or poultry feed. The KAHL expander. So here we have a design of a line equipped with the expander. So where will be the expander installed? So below the pre-bin, we have the feeding screw, the conditioner where we will inject steam and water. Then we install the expander below the conditioner on top of the pelleting press. Then the product will go to the cooler and the crumbler. We also sometime bypass the pellet mill to have expanded product, rather in mixed feed for layer feed or also for monocomponent treatment. Here is the table of thermodynamic with the moisture and the steam we are adding in the conditioner. So we can see that moisture of the raw material is frequently between 10 to 12%, and the temperature, ambient temperature, to 25-30 degrees. In the conditioner, we will try to reach a temperature of 65 to 85 degrees and end with a moisture of 13 to 17%. We can add water if the moisture is not enough high. Then we go to the expander. The moisture will not change at this stage, but the temperature will rise due to the energy input. So typically, the range is from 6 to 8 to 15 kilowatt hour per ton, depending on which formula we are treating. Out of the expander, we will lose some moisture due to the steam flash, and the temperature will drop as well. So out of the expander plus the pellet mill, we will reach somewhere around 11 to 15% moisture and a temperature from 80 to 95 degrees. Generally, the energy input of the pellet mill will be decreased due to the work of the expander. So we have less energy in the pellet mill. Then the cooler, we will get back to the 10-12% moisture. Expander prior to pelleting press. Generally, the expander are installed between conditioner and pelleting press. Work on any pelleting press brand. All the pellet mill in the market can be also installed standalone without pellet mill. Generally improve pelleting press capacity and pellet quality by the durability. When we install the expander, we always we can add a higher fat addition. The pellet mill will be less sensitive to the fats, especially for duck feed, which the fat will create slippery in the die and the roller. It will allow us to use a lower quality raw material, reduce the number of die used due to the pre-compaction done in the expander, and we will get a better lifetime, the roller and the die. The conditioning temperature is moisture and energy by kilowatt hour per ton have a significant influence in the parameter. So all the parameters are here to increase the pellet durability and can be changed during the operation of expander without resetting or without stopping the formula on progress. So the way we increase the pellet durability with the expander is rather by increasing conditioning temperature, but here we will keep the same conditioning temperature as a normal use of a pellet mill, increasing of the energy input inside the expander. So this part will allow us to have a better starch modification, to allow to have a better compression in the pellet mill. And the offset of water also can be increase of pellet durability. Here we have example for broiler feed. With base, we will go at 80 degrees of conditioner outlet. On corn base, we generally try to reach 85 degrees at the conditioner outlet. The energy input inside the expander will be, for the wheat base, from 5 to 8 kilowatt hour per ton, and from the corn base 6 to 10 kilowatt hour per ton. We need to have higher energy input for the corn since we need a better starch gelatinization. The starch of the corn is more difficult to modify than the starch from the wheat. This is our general experience in the broiler feed. For the additive, generally we see often application of additive in the markets in the batch mixer with mineral, vitamin, enzyme, and amino acid. We have also, this will not modify the physical appearance. Ideal post-pelleting application, so after cooler, we will apply sensitive additive like enzyme, the thermosensitive enzyme. This will be applied through a special machine rather than roto spray, what is our enzymer, and also can be fat added at that point. On some process, they will add the additive, the very sensitive additive in the drinking water for the birds, or the leak stone for the ruminants or the horse, cattle. So here we can see the retention of vitamin and enzyme after 3 months storage with the different process. These have been made by independent feed additive suppliers. So in the first line, we can see the pelleting, the process when the product go only with conditioner and pellet mill. In the second column, we have the retention on after conditioner, expander, and pellet mill. So we don't see a big variation from only pelleting or with the expander. The variation will be 5–10% maximum on some of the sensitive probiotic, for example, or vitamin C. But this will be countered by adding more vitamin C in the recipe. So here is application of the different additive in the batch mixer. So we have the different vitamin, and then the vitamin K, B12, or folic acid will be added in the enzymer or in the roto spray. Amylase is always also applied after pelletizing better than before. And probiotic living, which are very sensitive to the temperature. So here is what we supply for those cases, the roto spray. We generally can add 4 liquids from fat, from enzyme, from probiotic, and can be adapted to any process. The control system. So we have our own system for the control system. We call ASEP. So generally, it will allow the expander to run with the constant mode with kilowatt hour per ton, or through motor load, depending on the variability of capacity input. We will manage also the pelleting press, steam, water addition in the conditioner, and whichever brand of pellet mill you use in the factory. So that can be integrated directly to our control system. Our control system is a Siemens base. We have a reader personal computer, PC, or touchscreen available depending on the need. We will manage also the recipe. We have a recipe management system, can be integrated in any SCADA system. And we often use remote access for our engineer to access the plant or the line in case of troubleshooting. This is a view of our screen, so we can see the the expander with the different parameter, the kilowatt hour per ton here, the capacity of the line. So this plant was run at 26 tons per hour with a pellet mill of 900 millimeter die. And then we have the different data like the temperature inside the conditioner, temperature inside the expander, the amps or kilowatts used from each motor, and the temperature in the process. We have a recipe management system with data transfer from any SCADA. We store, we can load and store more than 100 recipe, and that it's the recipe can be named per customer and adapt at any time. So generally, in the recipe, we will have the profile of how to use the expander, what recipe, what steam, temperature reach, and the pressure. Now in the technical parts, how to see the wear detection. So the most common point in the feed mill is management of the spare part, and to know also when to change the spare part. So generally, we will have the manual supply with all the maintenance instruction, and a visual check at outlet will be done when you remove some stall bolts or when we open the door. Generally, a check of the expander, the spare part, and the wearing can be done in 10-15 minutes easily on the line. So no need to stop the line too long. So here we have the picture of the stop bolts. We have the screw inside and the thread. This is the cone. We have the lining. So how to detect the wear in the expander? So generally, when we will have a medium to a heavy wear, we will see a pumping effect in the machine or high power consumption. And generally, the hydraulic pressure and the power consumption will be unstable. The control unit generally will react to this and inform that something is not normal and have to be checked. Everywhere, the capacity will drop, and the more the wear is important, the more capacity is dropping. But that you will start to see this when you have 70-80% wear of the part. Now we have some data from the market. So we can see we have a high concentration of expander in Netherlands. So generally we will see Netherlands, Germany, Belgium. Mostly 100% of the feed mill will use expander to the high competitivity in the feed price. We don't see this trend yet in Southeast Asia, but starting to rise in Vietnam. We have a very good base in Japan, Korea. I will say 70-80% of the feed mill are running with expander on those two countries. Taiwan, we have a very good base. And we have also some base in Indonesia. The expander can be installed in any pellet brand, so Buller, Muyong. So here we have the example in Taiwan. And basically, we will see an increase of capacity, especially for the duck feed. The capacity will be increased by 100%, and we will see also a better quality. The high-fat broiler feed, we increase capacity of 50%. and same for the normal broiler. So this is due to a better cooking inside, a better preparation and gelatinization of the starch. On some different, so here we can see a question about if the expander have to be installed in a KAHL pellet mill. We are very flexible. We can be installed in any brand in the market, from Buller, Muyang, CPM, Andritz, and others. It is not, we don't have the need to be installed in KAHL pellet mill. And also, this can be installed in any line. On existing line, we will adapt. We have our engineer to design and to help to adapt the process depending on your feed mill. Of course, it will be much more easy if you have a new feed mill. It will be easy to integrate with a new machine. But on the old existing feed mill, we always find a way to install the expander. So in Vietnam, the screenshot we saw before at 25.9 tons per hour was on Van Arsene pellet mill, C900. So generally with 315 kilowatt, we will reach 25, 26 tons per hour for broiler feed. In duck feed, we see an increase of 140% of the capacity. Now to this plant, we have 8 expander, 6 running already on Van Arsene, CPM, and Triumph, and 2 new expander are being commissioned by December. Korea, most common pelleting price is generally the CPM 7730. So generally, we will see capacity for pig feed without expander at 15 tons per hour. And when we install the expander, we have 18 tons per hour with a better feed conversion ratio and a better PDI. In Europe, we have installed an expander on this very particular pellet mill, the Buller Cubex, which is made for high capacity, and the expander are performing up to 35 tons per hour. So there also we increase the existing capacity of the line. This was designed for cattle feed. Okay, let's go for the hygienic aspect. Generally, when we are in the feed mill, we don't want to see Salmonella, E. coli bacteria. And often in the raw material, we have the presence of the bacteria, the E. coli. In a normal or traditional expander, it's very difficult to kill those bacteria for the fact that those bacteria need to have a certain temperature through a certain time. But we know that past 100 degrees, all the bacteria will be killed instantly. So when we go through an expander, generally you will have the live bacteria before entering the expander with the raw material. Once it passes through, we have 0 E. coli last or Salmonella alive. We can see here the screenshot of before and after expander. Formulation optimization. So here also, if you have read the Feed magazine, was a very interesting article about how to save price cost of the formulation. So basically, when we have a formulation and use the expander, we will get a better feed conversion ratio and better metabolic energy. And if we adapt the formulation to keep the same metabolic energy, we can decrease the CPO and replace by lower cost ingredient like yellow corn. And the saving at the end, it's between 5.5 to $8. Those studies have been made on farm on a large scale. And even by reducing the metabolic energy of the formulation with the expander, we still get a better feed conversion ratio. So as we say at the beginning, expanders are generally a success for everybody in the feed mill industry, from the formulator nutritionist to the feed mill operator, to the marketing and sales, and to the farmers. So the impact of expander is generally increase of capacity in the pellet mill, increase of pellet quality for the PDI. We can produce different products like expander. It's a loose form before pelletizing. We also often use the expander for monocomponent treatments, which will allow us a better starch gelatinization. We will have an antitrypsin ANF reduction for the poultry, like the trypsin inhibitor, or also for the piglet feed. We will increase the bypass protein for the dairy feed. So all those advantages, we do it with different parameters in the expander. In the nutritional aspect, we have a better hygienization, improve of FCR, an increase of digestibility. The allergen will be reduced, especially for the young animal, which are much more sensitive. We will get a better starch modification. And this product will be much more easy to dissolve in water for wet feeding. And for the formulation, of course, we will always try to help to get a lower cost formulation by substitution of ingredient and optimization of the ingredients. So here, if you are interested for other seminar, for the market in Indonesia, the expander is still a very good product, but we have also the roller mill, where you have a very good saving in terms of energy, installation, and spare and wearing parts for the machine. Thank you for listening to this. Anyone have any question? So here, Mr. Thomas asked for the installation on a new line. And as I mentioned before, we don't need to install the KAHL pellet mill, the expander on top of a KAHL pellet mill. It can be installed on any brand in the market. Existing line or new line. Any additional question for this topic? Okay, so if you use an expander, those I need to change the formulation for my feed, or I can keep the same. You can keep the same feed, and of course you will get a better digestibility, a better FCR. But for you to save more on the cost of ingredients, you can improve your formulation by substituting some ingredients. Like we explained before, we can decrease the amount of CPO, which is very costly in the feed, by yellow corn, by wheat, or some soya, to a lower cost ingredient. We are also very successful by using lower cost local raw material, like copra, like palm kernel meal. We did a lot of trial on the rapeseed, on the cottonseed, So all these ingredients can be improved to give a better cost in the feed, or a better digestibility, better. At the end of the day, it's really to save money, to make a better price, or to decrease your cost. Thanks a lot for your time. Yeah, I think if we don't have more questions, we have a finish here.